Greeting, Professor. My name is Mui Hyang, and I will be presenting Project 3. So for our Project 3, we will be implementing the banker algorithm and experiment with it. So the banker algorithm, to put it simply, is just a way to check whether the process request will be fulfilled or not. So it's to check whether that specific process is safe to be allocated. If it leads to deadlock, the request will be rejected. So let's get into our code. So here's our class banker algorithm, and we have all the necessary variables, such as the number of process, number of resources, and our three vectors for our available max claim and allocation matrix. So this is just basically our simple constructor. And afterward, we will be prompting the user to input our processor resources and so on and so forth. So our allocation will be imprompt later. So after imprompting all of these above, it will just be allocated. It will be just fulfilled or initialized all to 0 for time being. So this is our main function. It's safe state. So basically this function is to check whether the request can be fulfilled based on the available resources as well as the process claim, whether that claim can be fulfilled. So it has a helper function, which is just to check the process need. Here is our request function. To put it basically, just to check the request, and if it's unsafe, it will revert back. So, and our release, yes, it's basically just releasing the allocated resources that the process hold. So, and this function is just to print out all of our claim, allocation, and available metrics of all the processes. And in our in domain, basically just here we're prompting user to input two command, whether it's request or release. And so I is basically stand for the process, and J is for the resources, and K is the amount of resources that they want to allocate or they want to release afterward. So this is just to check if the request is rejected or granted. It will be printed on our screen. So let's get into our program and run it. Okay, let me clear this a bit. Okay, enter. So we will put 3 for all. Each request is okay. Let's put perhaps maybe let's just put all 3. Okay, now we have to input our claim. So the first one is our first process. So maybe we can okay. So here's our process. So enter your command in the request. So let's try requesting. So now all of the resources are available. None are allocated. So it won't be a problem for us to request any of it. So let's see. Let's request for our first process. We'll request resource 0 as well, and then maybe allocate 3. So let's continue. So we can see that our resources has been allocated looking at our matrix, and our available resources for resource 0 is now all empty. So that means process 2 is unavailable to request resource 0. So now let's try to look for deadlock request. Let's go for request 1. So okay, 3. So it's granted because based on our available resources, resource 1 is still available. So that means the process 1 can still fulfill its claim. But if I were to create a deadlock, by requesting our resource process 2 with resource 1, and then we allocate 3 unit of resources, the request will be rejected because it will lead to deadlock. Unless one of the other two processes release its resources, the only available process that is able to request now is only process 1. Because if process 2 requests the current command at the moment, it will lead to deadlock. So that's how we avoid deadlock with the banker algorithm. Thank you for listening to my presentation.